Proving trig identities using even and odd properties. In our last video, we talked about the even and odd properties of all the 6 trig functions. We said that sine and its soulmate cosecant, tangent and the soulmate cotangent, that those were odd functions, which meant that the negative on the inside could move to the outside. And then cosine and secant, soulmates, they are even functions, which means that if there's a negative on the inside, you can just like destroy it and pretend it was never there. So we're going to use these properties and prove identities. Same thing we were doing before, starting with the left-hand side. Let's see, make that a little smaller. Starting with the left-hand side, we have 1 plus sine of negative x divided by 1 plus cosecant of negative x. And this is supposed to eventually become equal to negative sine. So the first thing I know and that I see is we have sine of negative x. And I know that sine of negative x is equal to negative sine of positive x, so negative sine x. And on the bottom, I see that cosecant of negative x is down there. Cosecant is sine soulmate, and it is also odd. So cosecant of negative x is negative cosecant of regular positive x. I'm going to make those replacements. So instead of 1 plus, it's going to become 1 minus sine x. On the bottom, instead of plus, it becomes minus. So 1 minus cosecant x. For that step, we used even and odd properties. On Alex, it just lists them as together, even, odd. So technically we used odd properties. That's what we really used here. But it's listed on Alex as one rule, so I'll just write it that way. So from here, I think, well, I know cosecant x can be turned into sines, so maybe that would be useful. Not sure. Let's try. So 1 minus sine x on top, 1 minus 1 over sine x. Maybe I'll make that blue. 1 over sine x. And that is using a reciprocal identity, reciprocal. I want to get rid of the denominator that's in my denominator. So I'm going to multiply the big fraction. You have to do it on top and bottom by sine x. And if you distribute, just to see what happens, sine squared x, not sine squared, just regular sine x. Sine x minus sine squared x. On the bottom, the sine x will get distributed. So you have sine x, and then for when it distributes to this next one, it'll cancel. It'll just become a minus 1. So this is when I come back and I say to myself, okay, well, where was I trying to go with this? I want to turn into sine x. And I made a choice right here to distribute on top and on bottom, distribute. And I want to show you previously, I've made different choices. You'll notice here, I said, hey, I'm just not going to distribute this. I didn't distribute this out. And you'll notice that something canceled. And you're going to find that that's a frequent thing that happens here. You're doing something where distributing should happen. And it turns out maybe it would have been better to not distribute because maybe something would have canceled. So what if instead of sine x minus sine squared x here, what if instead of doing that, we had done, leave the sine x, that red sine x, maybe I should make him red so we can see, that's the red one, right? This guy here, sine x on the outside, and you have 1 minus sine x. That would be this part right here. Now, here's an interesting thing. I see 1 minus sine x on top and sine x minus 1 on bottom. And I want to point something out. If you have a minus b, this is the same thing as negative the quantity b minus a. If you want to check me, you're going to go ahead and distribute the negative to both of these. So you have negative b plus a, which is the same as a minus b. There, I just proved an identity to you. This is an identity. A minus b is the same thing as negative b minus a. Pull the negative out, swap the order of subtraction. If I were to do that here, because all I have done is algebra, if I were to do that and pull a negative out of this 1 minus sine x, I'm going to put that negative out front. There's the sine x. So this sine x here is this red sine x here. The negative I'm pulling out is because I'm going to swap the order of subtraction here. So I'm going to do sine x minus 1 as opposed to 1 minus sine x. And that's great. Maybe I should highlight this. Okay, this 1 minus sine x turns into negative sine x minus 1. On the bottom, you also have sine x minus 1. And all you did to get here was algebra. These sine x minus 1s cancel. You're left with negative sine x. And that was what you were trying to do. That was algebra you did. Algebra. That is the right-hand side. That was what we were aiming for. So we'll put ourselves in a smiley face. Boom. All right. Very last, okay. There's not another video after, I was gonna say, this is the last page. The very last page is all of the identities and all of the things that we talked about today. So Pythagorean, reciprocal quotient, odd, even, all on the last page here. So there's no last video to go along with that page. This is our very last problem from this section. Let's do it. We have secant of negative x minus sine of negative x, tangent negative x is equal to cosine x. Our left-hand side, secant of negative x minus sine of negative x, tangent negative x. And I know that cosine and secant are both even functions. So secant of negative x is just secant of x, the negative gets destroyed. Sine of negative x you can take that negative that's inside and bring it outside. So negative sine of x. And same darn thing with tangent. Tangent of negative x is equal to negative tangent of positive x. I'm going to make all those replacements. So I have secant of negative x becomes secant of x minus, this is negative sine of x. Tangent becomes negative tangent of x. And we used even/odd properties here. We have a total of 3 negatives, which means it stays negative. So we have secant x plus sine x tangent x. My thought process is change everything to sines and cosines. Because Alex is a little bit tricky with this, you do need to do this in multiple steps. So you'll start with, like, let's say secant. Secant is reciprocal rule, 1 over cosine x. And then leave sine and tangent alone. Oh, and also the previous step was algebra. This step was a reciprocal identity. Now I'm going to change tangent using the quotient identities. So we have 1 over cosine x plus sine x times tangent is sine x over cosine x. That was a quotient identity. Now these both have the same denominator, so they can be combined into one fraction. We have 1 plus, and then sine x times sine x is sine squared x. Oh, someone's probably thinking like, what in the world? Make sure you fix this. I had a plus there. I had said out loud minus, and then I just continued to write pluses. I was like, oh no, this isn't turning out. No, this should be a minus here. 1 minus sine squared x, so that things can work out for us over cosine x. That was an algebra simplification. I see that 1 minus sine squared x on here is a, where am I going to write that? 1 minus sine squared x, that's a Pythagorean identity. It's equal to cosine squared x. So we have cosine squared x divided by cosine x. Cosine on the bottom and one of the ones on top cancel. And you're left with just cosine x. Oh, what happened from here to here? That was a Pythagorean identity. So I'll just write Pyth for Pythagorean. And then we did algebra to simplify. And we got the right-hand side that we wanted. So we put a smiley face. And there it is. All right. Those are, that's proving identities. It's kind of fun. It's very methodical. I will post a video on how to use the Alex tool so that part's not a challenge. Have fun with it. Don't be afraid to be wrong. Do your best. And if you have questions, send me an email. Otherwise, I'll see you guys in the next section. Bye.